Good afternoon, everyone.
Afternoon.
Thanks, Mr. President, for giving the opportunity to present my work in the conference. So I'm going to present the long-range teleoperation system based on IoT. So we are going to discuss about what is teleoperation system, then discuss about teleoperation system in the field of robotics, a little bit about Internet of Things, and the discussion includes also the architecture and the cloud platform for Internet of Things, and then our proposed teleoperation system, and then we are going to compare it with the existing system, and then it's going to conclude. So what is teleoperation system? A teleoperation system is exactly controlling the robot or any device from distance. Since user cannot directly see the robot or the device, so there is some kinds of feedback. That means we need some feedback from distance. So different type of feedback that we use. Mainly that we use live video from video cameras. Sometimes we use the haptic such as touch or vibration. Sometimes we use the audio tip, human ear range. Sometimes we use temperature and contact sensor or sonar images. Here is the typical setup of a teleoperation system. You see there is at the workstation there is a robot and some cameras are there. And the remote station, there is an operator that can control the robot from the video feedback. About me, I am Dr. Mohammad Salah Uddin, and recently completed my PhD from Sapienza University of Rome. And before that, I completed my BSc in Computer Science and Engineering in 2012 from East West University, Bangladesh. My research domain I mainly focused on heterogeneous robotic system, path and motion planning of robotics, multi-robot system, artificial intelligence, IoT robotics, sensor, and systems for robotics. As well as I am also interested in computer vision and deep learning technique. Okay, let's talk about the application domain of teleoperation system in robotics field. So teleoperation system is mainly used in space because the difficulty of access, difficulty of presence of human in that space, and sometimes it's not possible to there. So if we want to explore the sun, it's not possible for a human to go there and control the robot. So in that case, we must need a teleoperation system. So here you see the space robot of NASA and the space rover of Mars. They are really operated from the ground station. Nowadays, in military operation, teleoperation system is widely used to control the robot for knowing the information about the base, enemy base, as well as recognition, as well as in US they are doing some bad thing with the robotics that they can throw the bomb using the drone. Actually, this is the picture that comes from that the drone that is used for throwing the bomb on Israel. Sorry, on Iraq. They use this robot for carrying the bomb and throw it from the base station. In rescue operation, actually we use this is the robot that we used for rescue operation. So rescue operation is really dangerous. Sometimes there are lots of toxic gases up there, and sometimes there are some lots of dangerous things are there, and it's really harmful for human and rescue dogs. In that case, if we send a robot that can able to perform the operation, it will not totally perform the operation. The robot can be used for monitoring the environment, take a map of that, as well as the rescue team goes there and do the rescue operation more efficiently than the manual one. So the robot helps the rescue team for doing the rescue operation more efficiently. So nowadays, most of the police stations use robots for surveillance, as well as in Japan, they use the second robot for stopping a person by spraying keep on gas. That robot can be operated by from the ground station. Hazardous duties like as bomb disposal as well as toxic gas detection. This type of operation now successfully done by robots, and those robots are teleoperated from the ground station. In our agricultural field, the teleoperation system has a wide application currently. So currently we are use most of the company also use the unmanned aerial vehicle for monitoring the crops, as well as they also use this type of vehicle for spraying the fertilizer and insect clear. So now let's talk about the Internet of Things. Internet of Things is proposed by Uddin in 1999 in MIT. IoT refers to the connection of device, and lots of devices connect together, communicate together, not only the computer and the mobile phone. Rather than computer and mobile phone, there are lots of little devices that can communicate with each other, such as cars, keychain appliances, heart monitor device, etc. So here the most common architecture of Internet of Things. So here we divide the architecture in three parts. On that part there is a physical layer. You can say here all the sensors and physical devices are there, and the middle one is the networking. Actually, the cloud platform. So any cloud, you can use any type of cloud for that platform, as well as you can build your own cloud. It's possible also. And here is the application layer, where user application for the consumer application or the controlling application stands on that layer. At present, there are lots of companies provide the IoT cloud service. So cloud service are actually used for collecting data from the device, physical device, and send this data to the consumer device. So most commonly used cloud services are Amazon Web Service, Microsoft Azure, ThinkOps IoT platform, IBM Watson, Cisco IoT Connect, Salesforce IoT Cloud, Oracle Integrated Cloud. This is our system architecture, where we use a mobile robot, Pioneer 380 for this experiment. So the robot is occupied with a notebook computer, where all the drivers that can use to control the robot, as well as we need, since our system depends on internet, and we need to connect this system to the internet, so we must provide constant internet connection. So as a result, we use the 4G modem for connecting this robot to the cloud. On the other hand, the IoT cloud connected device such as mobile phone, or you can also use a little device, embedded device for controlling a robot. So that also must be connected to the cloud. The device, how it works? The device sends the information, controlling information to the cloud, and the robot receives that information from the cloud and execute the operation according to the command. Here we have a mobile application. We also develop a web application for controlling the robot. So for the mobile application, that is directly connected to IoT cloud, and the robot is also connected to the cloud. So the robot receives the information from the cloud and execute the information. Here we develop a robotic application that translates the high-level command that comes from the cloud and send it to the robot. Robot needs a special type of command. So that application convert the high-level command to the robot executable command. So now let's Let's show you a little demonstration how it works. So here, my robot is directly connected to the internet through the 4G modem, and I'm controlling it using my mobile application. You see, my mobile is also connected to the cloud. So when you see, so there is a, so if I say left, the robot moves left. So right, now right, right. And stop. So this chart shows the comparison of the existing teleoperation system that currently used. So if we compare the range, so since our system totally dependent on internet, so this is the main drawback of our system, but we can cross the range limit. So in conclusion, I said that, so yes, it's possible to, without using this system, if we use the satellite-based communication system for controlling the robot, it's really costly and it needs a special type of authentication from the government. On the other hand, we can use the lots of machineries to improve the range of the existing system, but it is really complex. So by contrast, our system, although it's dependent on internet, but it's cheaper. We are able to control the robot from anywhere remotely. And that's all about my talk. So really little talk. Okay. So question, comments, suggestions.
This paper is open.